订单敏捷响应加供应链韧性的体系，以 AI 系统实现订单评审与库存精准匹配，将需求、库存、生产和交付闭环管理，并引入 Gen AI 技术识别潜在供应风险，持续优化策略，打造海辰储能敏捷坚韧的供应链网络，显著提升运营质量，库存周转天数减少28%，交付周期缩短43%，交付率高达99.5%。我们专注于高安全、高能效、高一致性、长寿命、极致成本的储能产品研发。自研 AI 参与正负极材料筛选与性能预测，以 AI 加仿真技术预测产品寿命表现。根据 LightGBM 的电芯热失控安全性预测与设计寻优，推荐最优设计方案。多技术协同下，打通了从材料到电芯的设计链路，在提升设计敏捷性和产品可靠性的同时，将研发周期缩短31%，以智能驱动创新，打造极致的储能产品。智能制造是海辰储能的核心竞争力。我们深度集成自动化技术，构筑起低成本、高效率的制造壁垒，在产线上实现89%的自动化率，高微工序全面无人化。通过自动化仓储物流系统，无缝衔接跨楼层、跨厂房的智能搬运，在品质上恪守零缺陷理念，构建起预测、控制、诊断的智能质量体系。应用 AI 的 SPC 系统进行实时预警与闭环优化，保障电芯一致性。借助人工神经网络实现图步闭环控制，提升面密度一致性。引入 LightGBM 模型预测电芯容量及跨工序调参技术，可提前10天预知容量测试结果并进行调优。融合机器视觉与液态镜头，实现卷绕裸电芯全自动检测，零漏检。融合光电传感与深度神经网络，连接器激光焊接虚拟测量技术，实现快速检测。进 AI 赋能驱动质量异常根因分析与闭环管理，实现制程质量全流程智能化升级。该体系推动不良率下降57%，报废率下降58%，质量成本降低61%。在设备运维上，实现了从被动维修到主动智维的进化。依靠 PHM 进行预测性维护，让关键设备的意外停机时间降低了70%。通过 LLM 智能分析故障根因，让平均修复时间缩短了29%，整体故障率下降了35%。在运营上，通过数字孪生技术搭建智能制造运营平台，实现数据驱动的智能决策，关键异常事件及时响应率达90%以上，提升运营管控效率与精准度。这套贯穿制造全链的智能体系，不仅铸就了持续精进的生产效率与安全可靠的质量防线，更确保了海辰储能在全球市场中制造竞争力的持续领先。智能制造的本质是人的智慧与创造力。海辰储能以自由、创新、共享、友爱的核心价值观，汇聚全球优秀人才，构建起支撑技术突破与制造升级的核心力量。在人才运营中，我们深度融合智能系统，通过 AI 实现人岗精准匹配与一站式入职，提升组织效能。借助 VR 构建沉浸式培训场景，将培训周期缩短33%。海辰储能以科技赋能人才，以人才引领制造，共创储能新生态。 在可持续发展领域，海辰储能致力于推动各行各业绿色发展，锚定2032年实现运营碳中和，力争在2042年达成全价值链碳中和。在实践方面，海辰储能将绿色低碳贯穿运营始终，应用光伏智能管理、能源精控及暖通 AI 智控等技术，使单位能耗下降26%。双碳管理，依托 LCA 模型驱动全价值链减碳。聚焦当下，拥抱未来。海辰储能正以技术创新为驱动，智能制造为基石，为全球客户提供全场景定制的一体化解决方案，持续为全球能源转型注入新动能，让绿色能源的福祉真正惠及更多人群。海辰储能，专业让能源更安全。
什么是海辰人？
我想看看这样的精神到底在哪儿。
海辰是一帮用自己所有的精神、信心去拼到底，不拼到第一名不会放弃的一群人。
我要挑的是跟我的同路者、同行者，我要挑的是认可海辰这么搞的。我觉得这个就是我希望能够通过这个游戏也好，这个活动也好，一届一届的传承下去。
Hello， 大家好，我是中国能源报玉鑫。
Hello， 大家好，我是七七，欢迎来到海辰储能的直播间。
那我们现在正在海辰储能生态日的现场了，这也是我第2次主持海辰储能生态日发布会了。那么其实我们看到整体氛围是非常非常强烈的，同时呢，它也积攒了很多的能量和带我们开拓了视野。而且我看到这也是海辰从产品迈向生态的一大进步。
是的，那像我的感受呢，其实还多了一层。作为海辰人这是我第1次从线上来到了线下，可以在现场看到那么重要的一场活动，非常的有归属感了。
好，那跟着我们的脚步一块儿进去看一看，本次海辰储能生态日给大家带来了哪些惊喜呢？门口已经聚集了非常多的嘉宾了，所以跟着我一块儿去感受一下能源觉醒新世界吧。哇，今天真的是人非常非常的多呀！
对，这边有一个签到环节，我们可以先过去签一个到。
好，让我们看一看签到处有没有什么小礼品之类的啊。 你好，我们来签到。
你好，可以出示下您的二维码。
好。
这是您的2个游戏，2个的话可以抓娃娃。
好的，这边有看到您的信息。
好，请问你的签到。
你好，扫码签到。
这个是2人的一个手环，然后稍后入场的话会可以用一下，然后还有用餐也是可以出示。这是我们的一个游戏币，
是可以戴在手上。
对，然后的话
给大家看一下啊，我得到了一个手环，蓝色发光的手环，还有我们的游戏币。这个游戏币之后有什么用处呢？稍后再告诉你。
好的，我也非常好奇啊。那像其实从签到环节就可以看到我们海城储能的用心准备了。
是的，没错啊。其实，在这样的一个比较盛大的发布会的时候呢，我看到有很多标志性的logo， 就像我对面的这个 logo 呢，就会有一个蓝色的栩栩如生、非常生动的水母的形象。我很好奇啊，这个水母是有什么特别的含义吗？
其实啊，它的设计理念来自于灯塔水母。灯塔水母呢，有一种非常神奇的能力，叫做永生。
哎，永生是什么意思呀？
其实啊，就是当灯塔水母在受到外界致命的伤害，或者呢衰老到一定程度的时候，就可以通过它体内神奇的逆生长循环啊，让自己重新回到健康的状态。而我们海城储能呢所秉持的永续发展的理念，正是希望可以通过我们的产业技术，让绿色能源高效循环，生生不息，最终惠及全人类。
哇，这个水母可以相当于是完美的诠释了我们海城储能生态日的一个理念呢。好，那我们接下来即将进入到下一个区域啊，即将进入到下一个区域的话呢，一起来看一看下个区域给大家带来什么样的惊喜吧。这个区域啊，为我们展示了有常识储能展示区，还有 AIDC 储能展示区。那映入眼帘的呢，是一个来自于海城储能产品演示的时间长廊了。好，在这里呢，也请琪琪为我们简单讲解一下。
当然可以了。在这边呢，大家可以看到我们海城储能2小时、4小时产品，想必呢大家都已经非常熟悉了。但是呢，今天在这里，我们准备了为8小时全天候绿电而生的产品。今天呢，也是我们的重头戏，大家可以敬请期待一下。
期待住了啊！我觉得在这里呢，有非常多的悬念还在等待着大家。就像我们身后的 AIDC 的一个沙盘，哎，这个沙盘的话，它整体的一个规模也是非常非常大的。那请琪琪来给我们再次讲解一下。
当然可以啦，这个沙盘啊，是我们围绕 AIDC 智算中心打造的储能解决方案。至于具体的技术亮点和应用价值呢，这里也给大家留一个悬念，稍后啊我们会一一发布。
好，我也是非常非常期待，我感觉今天悬念很多，惊喜也一定很多。
是的，
马上就要用到我手中的小硬币了。大家知道这个硬币有什么作用吗？其实啊，就在我们后面的抓娃娃机。好呢，我们可以一块儿用硬币去看看今天幸运儿属于谁。
看来啊，这个娃娃机非常的受欢迎，
对，非常让我们欢迎，我们排一下队啊。你们觉得他们会抓到吗？我们猜一下啊。哎，已经抓到了，看一下我们是不是也一样的幸运。好，我先试一下，抓一个最上面的小水母。
这个看起来比较好抓到。
一次就中了。来，我们请琪琪试一下，看会不会抓到我们的这个小心。
我也来抓一个和你的同款水母。哦，差一点点，
差一点没关系。好，那我们希望后面的朋友啊，可以去抓到我们的小心。那这个区域呢，就是 AI 心动拍照机了。哎，琪琪，你之前有用过吗？
没有啊，这是我第一次看到这样的设备，其实我也很好奇它是怎么使用的呢？
那今天我们就尝试一下啊。我听说这个 AI 心动拍照机，它可以将我们的个人形象生成一个卡通的形象。好，一起让我们试一下。 我觉得这个海风很好看哎，可以尝试一下。好，带着我刚刚抓到的小水母，我们一起来跟它合个照吧。好，我们的 AI 心动拍照机的生成呢，大概是需要10秒钟的左右的一个时间了。所以在这个等待区域的这个时间呢，我们就可以看到一会儿卡通形象是否和我们2个人有一些出入呢？稍微等待一下，哎，已经出来了。
非常的还原呢，你看我们的小水母，
超级可爱啊！整个的背景也是栩栩如生的，像在海边一样。好，那这里呢就是我们整个互动体验的一个区域了。下面还有5分钟的时间，海晨储能生态日的发布会即将就要开始了。让我们一起感受能源觉醒新世界，一起看常识储能，开启智慧未来吧。
Channel. Thank you for your support and cooperation. We would like to remind you to leave the interpretation headset at your seat after the event, which will be collected by the service staff. Thank you for your cooperation.
自2019年创立以来，海晨储能始终专注于储能领域，坚持技术创新，坚定全球化战略，短短数年间实现了跨越式发展。成为全球锂离子储能电池出货量。
尊敬的各位来宾，欢迎来到2025能源觉醒新世界海晨储能生态日的现场。距离大会正式开始还有5分钟，请大家有序地落座。为了保证最佳的参与体验，请各位嘉宾佩戴好同声传译设备。感谢您的配合。Distinguished guests, welcome to 2025, the Awakening of Energy, the New World HiTHIUM Eco-Day. Our event will begin in 5 minutes. Please take your seats in an orderly manner. For the best experience, you should wear the simultaneous interpretation headset. Thank you for your cooperation.
应链韧性的体系，以 AI 系统实现订单评审与库存精准匹配，将需求、库存、生产和交付闭环管理。我们专注于高安全、高能效、高一致性、长寿命、极致成本的储能产品研发，自研 AI 参与正负极材料筛选与性能预测，以 AI 加仿真技术预测产品寿命表现，根据 LightGBM 的电芯热失控安全性预测与设计寻优，推荐最优设计方案。智能制造是海晨储能的核心竞争力。我们深度集成自动化技术，构筑起低成本、高效率的制造壁垒，在产线上实现89%的自动化率，高微工序全面无人化；在品质上恪守零缺陷理念，构建起预测、控制、诊断的智能质量体系。
尊敬的各位来宾，欢迎来到2025能源觉醒新世界海晨储能生态日的现场。距离大会正式开始还有3分钟，请将您的手机调至静音模式。尊敬的各位外籍嘉宾，为了确保您能全程投入后续环节，请提前佩戴好同声传译设备。感谢您的理解和支持。能源之旅即将启程。Distinguished guests, welcome to 2025, the Awakening of Energy, the New World HiTHIUM Eco-Day. The event will begin in 3 minutes. Please switch your mobile phone to a silent mode. To better follow the upcoming procedures, please ensure that your interpretation headset are worn in advance. Thank you for your understanding and support. Our journey is about to begin. Thank you.
双碳管理，依托 LCA 模型驱动全价值链减碳。海晨储能正以技术创新为驱动，智能制造为基石，为全球客户提供全场景定制的一体化解决方案，持续为全球能源转型注入新动能。 让绿色能源的福祉真正惠及更多人群。海晨储能，专业让能源更安全。
现场尊敬的各位来宾，欢迎来到2025能源觉醒新世界海晨储能生态日的现场。我们的大会即将开始，请各位嘉宾尽快的入座，并将您的手机调至静音状态。外籍嘉宾，请您确认已佩戴好同声传译设备。感谢您的配合和到来。Distinguished guests, welcome to 2025, the Awakening of Energy, the New World HiTHIUM Eco-Day. Our event is about to begin. Please take your seats as soon as possible and switch your mobile phone to a silent mode. Please confirm that your interpretation headset are properly worn. Thank you for your cooperation and join us today. 掌声有请。
Let's warmly welcome the co-founder and CEO of HiTHIUM, Mr. Jason Wang Pengcheng, to unveil a new prelude to our energy exploration journey. Hello, everyone. Welcome to the Awakening of Energy, the New World, HiTHIUM Eco-Day. I am Jason Wang from HiTHIUM, and I am very pleased to reunite with both new and old friends once again. Last December 12th, we gathered in Beijing for our second Eco-Day. And today, filled with gratitude and warmth, and we have returned to the fertile ground where HiTHIUM's dream set sail and took root, the beautiful city of Xiamen. And here we together open a new chapter for the third grand gathering. And here I would like to express our gratitude to Professor Tan and all leaders and experts for your guidance and presence. And thank you to the competent authorities at all levels in Xiamen, as well as China Communication Industry Association Data Center Community, the Energy Storage Branch of China Battery Industry Association, Xiamen Association for Science and Technology, China Energy News, and IDC Nova, and other supporting organizations. Thank you to friends both here and online for your companionship and witness. A warm welcome to you all. So now, as people continuously pursue a better life, the whole world is rapidly entering into a new era of electrification and intelligence. However, severe challenges lie before us. The global electricity shortage crisis is accelerating, and the future electricity demand growth will far outpace the overall increase in energy supply. To discuss energy is in essence to discuss the very foundation upon which civilization persists. So I'd like you all to ponder a question. What if the world lost the power? The lights in the city would go dark instantly, and data centers would come to an abrupt halt. AI computing power would be forced into dormancy, and even the sound of our breathing right now would become unusually clear. And this reminds us that energy and electricity have never been just infrastructure. They are the underlying logic of modern civilization, and also the core capability that maintains the operation of all systems. If energy fades, civilization halts, and if energy awakens, civilization leaps. And this is the immutable truth of human history. And at present, we're at a critical tipping point in the energy revolution. On the one hand, green power is growing explosively, becoming the core engine for transformation. And on the other side, the explosive demand from AI plus and cities for stable, sustainable electricity is reshaping the load structure of power systems. However, the contradiction is deepening because traditional power struggles to support incremental demand, while green power is constrained by natural intermittency. So to transform green electricity from weather-dependent to stable and easy to use, enabling massive amounts of green power to support rapidly growing electricity demand. And the core pathway to achieving this transformation is energy storage, especially all-day, long-duration energy storage that spans days and nights and cycles. And in 2022, when long-duration storage was not yet an industry consensus, HiTHIUM took the lead in research and development. At the first Eco-Day in 2023, we launched the world's first 1,000 ampere-hour level long-duration storage battery system. At the second event in 2024, we launched the infant cell 1,175 ampere-hour, 587 ampere-hour batteries, and the InfiPower 6.25 megawatt-hour 224-hour system. And very innovatively, we released the first specialized sodium-ion battery. In the long-duration energy storage is HiTHIUM's unwavering strategic anchor. We always believe that the true industry leadership lies in daring to tackle the difficult, uphold the right, and create long-term value for society. And this year, amidst the wave where electricity computing integration has become an industry consensus, we focus on synergistic innovation between long-duration energy storage and AIDC. And this is not merely a technical synergy, but also representing HiTHIUM is transiting from a pioneer in lithium-ion long-duration energy storage to a co-creator of the industry ecosystem value. So based on this strategy, we further focus on application scenarios of long-duration energy storage, and we deeply integrate it with intelligent computing power and AIDC in specific contexts to promote implementation of the national strategy for green electricity computing integration. Because AI Plus drives the future and long-duration energy storage will be the most solid energy foundation. When electricity becomes the new petroleum, long-duration energy storage will be the strongest core for the perpetual operation of energy. This is how we see the trend in the future, and also an inevitable trend for us to pursue for the future, as well as a solid starting point for us to work together with our ecosystem partners to open up an intelligent future. If we look back at the history from Volta illuminating the first electric current to Tesla enabling electricity to light up the world, every energy awakening has changed the developmental landscape of its era. And today, we officially launched the all-day Green Power 135 Lighthouse Plan to undertake actionable initiatives to fulfill the mission of making green energy benefit all humanity. And we build the all-day green energy world with the long-duration energy storage as a lighthouse. And we've got 3 major actions: green intelligent commuting action to empower 100 AIDCs to achieve net zero carbon operation, and also our comprehensive energy storage action to implement more than 1,000 long-duration storage projects across generation grid load within a dense energy security network. And our Green Power Hub action, we will participate in building 10 million kilowatt level new energy bases, supporting the construction of a new power system. And by 2030, working together with our ecosystem partners, we will turn the blueprint into reality, letting the lighthouse illuminate all industries. Based on baseline scenario calculation, the 135 Lighthouse Plan will contribute to 437 million tons of cumulative direct CO2 emission reduction after 5 years, contributing to global net zero emissions and the 1.5-degree centigrade temperature control goals. So, dear guests and friends, the all-day Green Power 135 Lighthouse Plan is HiTHIUM's commitment to a green energy future, and also a pact with all our fellow partners. Let's use long-duration energy storage as a cornerstone so that we could open up a new world of energy awakening, one that is all-day, sustainable, and prosperous for all. Thank you all very much.
长时
Long-duration energy storage is becoming a pivotal force shaping the future of energy system, and this is growing ever clearer and more resolute. And now let's warmly welcome Deputy Chief Engineer and Director of Energy Innovation Research Institute of Electric Power Planning Engineering Institute, or EPPEI, Mr. Xu Dongjie, to share his insights. Please.
Distinguished guests, good afternoon. Thank you very much to HiTHIUM's invitation, and I would like to combine with my own work to briefly share with you. And due to the time limitation, I will briefly report to you. The first is the achievement that we have made in terms of the battery energy storage. The development of battery energy storage has had a great achievement. By Q3 this year, the scale of battery energy storage has already exceeded the 100 million kilowatt. And what does that mean? Because before we have mentioned about the installation of the energy, and for the battery energy storage has already exceeded a huge installation. And also in the national level, we have had a lot of policies to support the development of battery energy storage. So whether it's from the installation scale or the dispatch or the transmission level has witnessed a leap forward progress. And of course, we still have a lot of issues that need to be tackled, and also there are a lot of technology difficulties need to be overcome. There are many in two areas. The first is the difficulty in terms of the cost recovery. As we all know, that the energy storage, whether it's the grid connection or the different site, the overall, there is still a limited, and also we are lacking the very stable supply business model. So it's difficult to have a very good profit through the simple price support or the spread arbitrage. And the second is, as probably you know, in terms of the key materials or the core component, we haven't made fully breakthrough, and we are waiting for the technology maturity to be further improved. And for example, we have heard about the grid forming energy storage, and however, the overall support from a grid is not enough. And for the energy storage, especially for electrochemical energy storage, are still facing the safety operation issue. So overall speaking, there are a lot of key technologies still waiting to make breakthroughs, especially for the cycle life or the energy conversion efficiency of the energy storage system needs further improvement. And when talking about the development of energy storage, what I want to mention is what we are accelerating the construction of the new power system as well as the new electricity system. For the energy storage is a very important features for the construction of new electricity system. It can play a vital role in including the improving of the energy system resilience, promote the science and technology innovation and industry operation, as well as incentivize the economic growth. And whether it's the short-term or high-frequency energy storage, or the medium to short duration energy storage, or the pumped storage, they can all play their own features. And when talking about the energy storage, we're all quite concerned about the future of battery energy storage. So I think as long as we can understand its trend, what I say here is change and unchanged. Let's first talk about what is unchanged. The underlying logic for the development of energy storage has remained unchanged, especially for the high proportion of renewable energy. The randomization or the fluctuation requires the energy storage. The second is the strategic position of energy storage will remain unchanged, because in order to improve the system safety, economy, as well as the efficiency, we need to plus the storage on the basis of source, grid, and load. And then the second unchanged point is the cost reduction, as we could see that recently the energy storage price are going on a downward trend and the scale has recovered. So all in all, the cost reduction trend or the pursuit for cost reduction will remain unchanged. And the next one is safety. What I've already mentioned, the safety of energy storage, especially the safety of electrochemical energy storage requirement will remain unchanged. And then for the battery energy storage has already reached the 100 million kilowatt, and the majority of them are the electrical chemical, and the majority of that is the lithium-ion battery. So in the short run or the near term, its dominance position will remain unchanged. And now let's turn into what is changed. First is development mode will be shift from the policy driven to the market driven, as we could see that when the number 136 document has been published, and for the overall electricity market or the new renewable energy or the energy storage market has had huge influence. And of course, in the future, we have the 1,360 document will play a certain role as well. And then we could see that the policy orientation has shifted from the scale development driven to the high quality development driven. And currently, we have already installed a 100 million kilowatt. It's already become a very important energy infrastructure. Then the future development will definitely move towards the high quality development. And then it's the technology iteration is very fast, whether it's from the electrochemical energy storage, whether it's the 280 or the 340 or 14 or higher cell, or including the grid foaming technology or the safety related technology or the other technology route are making breakthroughs. So the technology iteration is accelerating. And then we are seeing the competition is becoming more and more complicated, which include the technological advancements or the overall elevation of the threshold, and also, as you could see, for some of the industry leaders are becoming more centralized. And then we are seeing a more balanced development in different regions. And in the past, the resources are more focused in the central west, and the Central East are more technology side. However, in the future, these will become more balanced. And the fourth, what I want to talk about is the long duration energy storage. From this table, as you could see, that the long duration energy storage can play the overall volume, green and energy value. And when we talk about the long duration energy storage, there is no clear definition, and currently which should be over 6 hours or 6 to 8 hours in the international standard. However, from our industry, we hope that it can trans days, weeks, or even trans-season regulation, which can meet the overall demand of the market. And for the actual function, we could see that the intraday imbalance or the multi-day imbalance or the extreme weather correspond or the grid stability, and all this can be helped by the long duration energy storage. When we talk about the overall development trend of battery energy storage, I wanted to talk about the innovation of battery energy storage, and we are more focusing on the several dimensions. The first is intrinsic technology innovation, and then we have the system integration optimization, and then we have safety enhancement mechanism, and the last would be the application scenario expansion. And I would say that in the 15th five-year plan, the all technology advancement of energy storage has remained unchanged. And as we could see, whether it's the compression air or the large volume flow battery or the sodium-ion battery has made further breakthroughs. And the lithium-ion battery has actually moving very fast on the previous accelerating path. And then we have the thermal energy storage or the hydrogen energy storage technologies will be further explored. And then we also need to study how long duration energy storage be applied in electricity system and how can we better apply it in the system. And I believe Mr. Jason Wang has explained very thoroughly. And now I would like to briefly report to you the mechanism setting of energy storage. As we could see that the pumped storage is because that we have two stepwise electricity price, and the battery energy storage at the grid side is promoting towards this direction as well. At the grid side, we need to consider the volume electricity price, and in the source side, and it has been hugely impacted with the release of number 136 document. And however, from the source side, if we want to have the energy storage, we're actually solving the randomization or the fluctuation of the power source. And this would be the trend. And this is something that we are making efforts to set up the mechanism. After talking about the energy storage innovation or the system setting, I also wanted to talk about the industry collaboration for the energy storage, especially battery energy storage. Industry has already become a pillar industry with a huge scale. I think the development of energy storage has made a great contribution from China for the world renewable energy transformation. And overall, we could see that industry scale is increasing. But also I wanted to say that the battery energy storage industry development is not only the upstream-downstream supply relations, it is actually constructing an ecosystem with technology, scenario, regional, deeply integrated system. Whether it's from the upstream, which include the batteries, converter, BMS, EMS, or in the middle stream for the system integration to the downstream terminal application. It has already formed into a complete ecosystem or the eco-chain. If any section falls apart, which will impact the whole system. So to build such ecosystem is for solving the issue that within the industry with a strong manufacturing, weak application, strong capacity, weak consumption, or similar structural conflict. So I think to have the energy storage, we still wanted to break through the fixed boundaries between the source, grid, and the load, and make the energy storage become a hub for the energy conversion. And in the meantime, we need to have the related policy, finance, and the standardization work. And probably you have already seen the document released by the State Council, which is about the implementation opinions on accelerating the cultivation of scenarios and promoting the large-scale application of new scenarios, which are starting from the technology innovation as well as the industry integration, which for the first time improve the large application of new scenario as the national level strategy. So I would say that the scenario is the key to bridging the innovation achievement as well as the industry demand. So if we only say the technology innovation or the system setting, or only trying to find the application scenario is not enough. So the nation has already published the document to define what does it mean by the scenario or the scenario cultivation, or especially the large-scale application, which has already identified the direction for us. Lastly, I want to share with you that, as you can see from the suggestion in the 15th five-year plan, they're saying that you comprehensively elevate the electricity system complementary and safety as well as the resilience level, and scientifically lay out the pumped storage and play effort in the battery energy storage. So the nation has already clearly identified that we need to make efforts to develop the battery energy storage, which is already the direction for us. So I think even though we are still having a lot of issues, however, as long as our industries can work together, we can realize a greater dream. And due to the time limitation, that will be all for my sharing. Thank you very much. Thank you very much, Director Xu Dongjie, for your wonderful speech, who has given us the analysis of the strategic position of long-duration energy storage in the new power system. And now we're going to invite Dr. Alex Cipolla, Senior Research Analyst of Wood Mackenzie, to deliver a keynote sharing from a global perspective. Let's welcome.
Welcome Dr. Alex Cipolla, Senior Research Analyst of Wood Mackenzie, to deliver a keynote sharing from a global perspective.
Thank you. Thank you very much for the invitation. I'm honored to be here. I'm Alex. I'm Senior Research Analyst at Wood Mackenzie. For the one of you that doesn't know us yet, we are a global business intelligence and data analytics firm. We have global presence, also 2 offices here in Zhongguo, and we are very active in the energy sector, and of course, we are very, very active in the energy storage space. Today, I will present to you the landscape of the long-duration energy storage. I will try to give an overview of the different technologies that are in this sector, and also how they compare with the lithium-ion batteries. So, first of all, a bit of context. Why do we need energy storage? We see that in the globe, at different velocity, we see that there is higher penetration of renewable energy. And this demands flexibility from the energy grid. Thus, energy storage is fundamental. But not all the energy storage comes in the same form. We have different duration and also different classification. Here, I represent on the right side different technologies and their discharge duration. So you see that traditionally lithium-ion batteries as well as sodium-ion batteries were not considered long-duration storage, while other technologies are able to give higher duration. But also we cannot consider the long-duration energy storage as a monolithic group of technologies, because it's very different if you have a storage that lasts for 10, 24 hours or 100 hours. So in the previous slides, I give you an introduction of why we need energy storage. In this slide, I'm trying to represent why we need long-duration energy storage. Traditionally, the traditional lithium-ion batteries of 1 or 2 hours duration were very good for maintaining the stability of the grid and contributing to the peak capacity. But they were less good in, for instance, addressing multi-day imbalance or seasonal imbalance, or even responding to extreme weather events. And this is where we need long-duration energy storage to fill the gap. Of course, you can also have other tools to provide flexibility to the grid, but in this presentation, I will just focus on these 2. Here, we represented the new technologies that are coming to the market in the long-duration energy storage space. Of course, we took out lithium-ion batteries, which, as you all know, it's a very mature technologies, and we divided the in 3 categories that are in the way that they store the electricity. One is electrochemical storage, which is like lithium-ion batteries. The other one is mechanical, and the other one is thermal. We do this every year, and every year we see that there is innovation in this space. We see that, for instance, vanadium redox flow batteries are becoming very, very close to be a mature technologies, as well as metal air batteries. We saw a lot of innovation this year. And then there is advanced compression air, and of course, also thermal generation that is becoming more relevant. Here, I show you the trend of the installation in these alternative technologies that we have seen in the past 4 years. As I confirmed the number of before, like 96% of the market is still lithium, but here I want to focus on the alternatives. As you can see, these alternatives are growing with a very fast rate, almost 100% every year. There is still a bit of variation, which is mostly due to the fact that it's a market that is in its infancy. So you see like a lot of variation within the years. In terms of the regions in which this alternative long-duration energy storage are installed, China is still dominant with 92%, while other markets are quite marginal. And also it depends a lot on like which kind of big storage project get installed in which country. For instance, in the example of Africa, that 4% is just one huge long-duration energy storage in South Africa, which means that this alternative market is quite in the infancy. Here, on the other hand, I represented what are the different technologies that got installed in the last 4 years. As you can see here as well, there is a lot of variation year over year, which is still a sign of the infancy of these technologies. We can see some trends. For instance, lead carbon batteries were mostly installed in 2023 and 2022, while in the latest year, we see less installation, almost negligible. Advanced compressed air is becoming a staple of these alternative technologies, 52% in 2025, as well as thermal energy storage. It's an important part. And as I said before, we saw that vanadium is really becoming a mature technology and coming to the market. Here, on the other hand, there is a representation of whether these technologies are on the utility scale or grid scale, or they are in the CNI. And there is a stark difference between China and the rest of the world. While in China, we see that 94% of these alternative technologies are in the utility scale. In the rest of the world, CNI is still the dominating sector. But as I said before, this is more a sign of the not maturity of this market rather than a structural difference between these regions. Like China's 27 gigawatt hour of installed capacity, while the other one don't even arrive to 1 gig. And here it comes, I think, what is the main block that these alternative technologies have with respect to lithium ion. So in this chart, you can see how the cost of these alternative technologies is compared to lithium ion average in China, which is 1 over there. And you can see that in most of the case, these technologies have a cost per kilowatt hour that is higher than lithium ion, thus not making them economically competitive with lithium ion. And on the other hand, as well, we have to consider that there is a round-trip efficiency of this technology, which is the ratio between the energy that you can store in charge with respect to the one that you can discharge. And all these alternative technologies have lower round-trip efficiency, which inherently gives an additional advantage to lithium ion. So I'm from Europe. I want to conclude this intervention with some results that we get from Europe, which also give, I think, a good sentiment of how the market is evolving. One from UK, the other one from Italy, where I'm from. So in the UK, this year, in April, it was held the first tender that was just targeting the long-duration energy storage. And the results were quite surprising because, like usually in the normal auctions, you have all lithium-ion, so they decided to make this auction just for long-duration energy storage. Still, lithium-ion won 70% of the capacity that was awarded. On the other hand, in the right side, you can see the results of an auction that was held in Italy. This, on the other case, it was only reserved for lithium-ion technologies, but the duration of lithium-ion that we saw awarded are unheard of, at least in Europe. We saw like 6 hours duration. The average was around 7 hours. We also saw a 8.5 hours duration. So what are the main conclusions out of it? Is that on one side, all these new technologies are quite important. It's also good to research on them, and also like especially the ones that are coming for over 1 day, so more than 24 hours duration, are really relevant for making the grids stable. But on the other hand, we see that lithium-ion every year is redefining what is its limit, because before we said, okay, lithium-ion is just good for 2 hours, then it was 4 hours, now we see even 8 hours, and so I still don't know when the limit is. I would say around 10 hours, but maybe I will be wrong again. So what we see in the future, at least in the close future, is that also in the long-duration energy storage, lithium-ion will be the dominant force, but the other technologies will be a niche, but you have to consider as well that this is a $1 trillion market, so even if a niche is still a multi-billion-dollar opportunity to be chased. Thank you.
非常感谢 Dr. Alex Cipolla 博士。
Thank you, Dr. Alex Cipolla, for your global perspective. And we see a common trend from your presentation. Short duration storage can no longer meet future needs, and we need longer lasting solutions capable of transcending time and space. And now let's warmly welcome Dr. Wang Wei, Director of the System Research Institute of HiTHIUM, to unveil our first major product of the day. Hi, everyone. Let me ask you a question first. Why do we need long-duration energy storage? First of all, on the demand side, electricity demand is growing rapidly. In July and August this year alone, monthly electricity consumption exceeded more than 100 million kilowatt-hour, or more than trillion kilowatt-hour. And looking ahead into the future, intelligence will be a core driving force for the demand for electricity, especially 3 key scenarios. First is the widespread adoption of electric vehicles. The intelligent vehicles consuming high computing power will lead the traffic revolution, and they will become the hub of the household computing power. By 2030, sales of EVs in China will be more than 70%, and globally it will be more than 50%. And for each vehicle, their energy consumption each year could range from 3,000 to 30,000 kilowatt-hour. And second is humanoid robots. By 2030, a large number of robots will work in factories and also serve universal households, and this means that they require like 100 million of hours training and data so that the robots could be used more universally. And third is the intelligent data center. They provide support to the core computing power of intelligence, and they may consume power to million kilowatt-hour as well. And this also shows strong volatility. On the supply side, however, the energy structure is experiencing in-depth transition. By 2030, renewable energy, including wind and PV power, will occupy 40% of the total power consumption, and globally they will be up to 25 to 30%. And as variable renewable energy is occupying a larger share, the intermittency of new energy need to work together with a more stable and flexible power system. And this poses a key challenge. And also, when the awful weather comes, short duration energy storage will no longer meet our need. The more new energy there is deployed, the huge demand we will have for the long duration energy storage. But how can we define long duration energy storage? First of all, we need to consider time. And we may need intraday regulation 4 to 12 hours, and also multi-day regulation 12 to 100 hours, and also seasonal storage more than 100 hours. And of course, we can see two categories of challenges. First is implicit indicators cost, including cost of power and cost of energy. So we could see that the cost of the whole station will be lower than that of the simple combination of short duration energy storage. And also efficiency is very important. It includes the charging and discharging efficiency, and also the loss of efficiency will also influence the configuration of the system. And at the same time, we need to consider implicit indicators, namely security and reliability of the whole energy storage system. And they will compose together the conformity or certainty and long-term value of the energy storage system. And then we could showcase the value of the long-duration energy storage. And for the intraday long-duration energy storage, what kind of challenges should we overcome? And today, HiTHIUM will launch the Infei Power 6.9 megawatt per 55.2 megawatt 8-hour long duration energy system solution.
Thank you very much. And today we're going to release the Infei Power 6.9 megawatt and 55.2 megawatt hour 8-hour long duration energy storage solution. And the whole solution is highly integrated standard unit with flexible configuration, and each standard unit with a power of 6.9 megawatt and with a capacity of 55.2 megawatt hour. For the standard unit is composed by 1 megawatt of a module and 8 BESS modules. And we have already optimized the hoisting and cabling design and simplified the grid connection procedure. Before we deliver, we have already had a high integrated prefabricate and with the overall validation. And also the impact design and has largely optimized the overall layout compared to the previous proposal. The overall size that we occupied footprint has reduced by 23%. Time is money and space insufficiency, the shorter construction cycle, and the earlier grid connection and power generation, which means that the owners can significantly reduce the investment cost and realize the benefit as soon as possible. And also, the HiTHIUM technology team is dedicated to provide the design and engineering service that meet the project needs. We have already pre-designed the standalone energy storage and the wind and photovoltaic storage integration and installation in extreme environments. What we delivered is not only equipment, which is a more standard plan that has been verified and expected investment return, and also the commitment for the sustainable development of energy. Probably you will ask how to reduce the cost. And we are mainly starting from two dimensions. The first is to continue with the great design of our system. For example, we have carried over the 20 feet fabricated module, and then our freight cost is the optimum. And on the such dimensions, the overall design is the optimal solution in the market for the volume and the weight. The second, we will not only reduce the cost by downgrade. However, through the function reforming and while improving performance, achieving cost breakthrough as well. Let me give you some examples. And we introduced the active safety zone design, which is similar to the watertight buckle hat. The waterproof, then now is the fireproof, and based on the thermal runway and the fire test and the fire simulation, HiTHIUM experiences, and we give the active safety zone enough protective capability. And in the safety zone, and we have transformed the passive fire protection into the active and a passive integrated fire protection, and which we isolation of each zone. And with the active safety zone, the overall structure design, structural optimization has become possible. We given up the onion type of cell pack battery cluster, this nested structure, and we integrated the certain amount of cell into the active safety zone, and also to save the use of redundant components. And this does not only reduce the material cost, however, it also improves the assembly efficiency compared to the market 6+ megawatt-hour system. The overall degree of integration has improved by 10% and efficiency and improved by 30%. The second is the backup power. The traditional backup power need additional lead-acid battery. However, all these lead-acid battery are in the idle status. We have reshaped the backup power architecture and abandoned the excessive redundant, and through the smart energy management to have the high voltage distribution, the new plan has decreased the weight by 52.5% and the space reduced by 54%, and also can provide over 5 hours backup power, which has 1 to 2 hours more than the traditional plan. Then how to improve operational efficiency? I think we need to find a more smarter method. Our system has already had a large amount of sensors and a high-performance computing platform. It is actually an energy intelligent agent. I would like to share 2 technical innovations. The first is energy-saving intelligent agent. The energy storage system itself is power-consuming. The single container will consume around 150 kilowatt-hour per day, and 90% are coming from the HAVC. The electricity charge of the owners is accumulating on a daily basis. The traditional thermal management strategy is not intelligent enough with poor temperature control precision, the low response and the higher power consumption. And HiTHIUM, based on our design, experiment, and simulation data, we have had a more refined modeling of our cell system on the site through the optimized the AI sensing, prediction, and control strategy, and we have hugely reduced the auxiliary power consumption. So what is the effect? The overall temperature control accuracy improved by 50%, response speed improved by 20%, and the power consumption of HAVC reduced by 30%. What does it mean? Assume 1 gigawatt-hour long-duration energy storage in the whole life cycle energy consumption can save over $5.5 million, which is close to 40 million RMB. The other technical innovation is the collaboratively address balancing issue. The inconsistent bottleneck cell will induce the round-trip efficiency loss. With the larger of the cells, the difference of the cell capacity will make the bottleneck effect more prominent. So we have introduced the cooperative control intelligent agent in the battery compartment. We have had the efficiency bidirectional active balance technology. Compared to the passive balance, the balance capacity has improved 20 times the balancing capability. Efficiency exceeds by 97%. From top to bottom in the site, the overall charge and discharge state has achieve the overall balancing of the intra-compartment cluster charge and discharge power to offset the impedance difference. And in the calculation, a more balanced system can bring a cycle efficiency to improve 0.2%. Assume 1 gigawatt-hour long-duration energy storage can bring over $1 million IRR benefit to the owners. And with a more economic and high-efficient solution, the next question we need to answer is how to guarantee safety and reliability. Without safety, then our energy storage system cannot it's impossible to talk about the asset values of the energy storage system. HiTHIUM is always put the product safety on the top. And also this year, we have had the world first large-scale open-door fire test. And on the basis of a traditional system safety, and we creatively create the product release and withstand protection system and to construct a more extreme safety protection for a larger cell. In terms of the protect, with the cell expansivity, with the too large or too small binding force is not benefit for the cell long-term operation. And we innovatively introduced the high-strength steel banding technology, which can provide additional 6-ton binding force and to protect every cell like the swaddling clothes. And in terms of the thermal runaway, our strategy is to release instead of block. In order to have the high temperature gas to be venting, we have designed a dual release valve to collaborate with the anti-explosion system. And the experiment has shows that we can release 120 liter or plus high temperature gas every second. And also the temperature reduced by 128 degrees. And also with the condition of heat propagation, we have used the multi-layer high-performance heat insulation materials, and they can withstand 800 degrees extreme high temperature and will not fail in terms even under the 300 kPa. And in the active safety zone, we can withstand over 1,300 high temperature to ensure there is no propagation. And apart from the hardcore safety, we are also focusing on the functional safety and the cyber secure safety. The HiTHIUM product conform to the IEC 62443 cyber security and IEC 61508 functional safety, and flexibly meet the diversified market safety needs globally, dedicated to make every energy storage station become intelligent and a credible energy cornerstone. And today, our integrated solution has made breakthroughs in terms of safety, efficiency, and safety, and prepared for the all-weather 8 hours long-duration energy storage. Infant power 6.9 megawatt and 55.2 megawatt hour will deliver in Q4 2026. Lastly, I would like to share a belief. The best energy storage system should make the variable renewable energy into a credible energy cornerstone. Let us work together to deliver a more reliable and a greener renewable energy future. Thank you very much. Of course, a strong system cannot perform without an even more stronger and more reliable heart. And now, let's focus on the champion cell for the long-duration energy storage. Let's please welcome the Director of Battery Research Institute of HiTHIUM, Dr. Wang, to give us the answer. Hello, everyone. I'm Eileen Wang from HiTHIUM. And I thank you very much to Dr. Wang for your wonderful sharing. And in his report, there was one very key opinion. With the extension of service time of our equipment, the long-duration energy storage has proposed a higher requirement to the economy as well as the reliability of our energy storage equipment. Now, here is the issue. Can existing 340 ampere 2-hour cell meet 8-hour energy storage requirements? And after in-depth study and validation and verification, we found out that the existing 2-hour storage cell are not the optimal solution for long-duration energy storage in terms of the economical and the reliability. Let me give you a simple metaphor to explain why 2-hour storage cells are not the optimal solution. If we compare energy storage system as a building, then the cell would be the bricks, and the 2-hour energy storage cell is more like the small bricks for the bungalow. And in theory, we can use them to build the 8-story building, however, which will consume a lot of bricks. And these will cause two practical issues. The first is the more components leads to higher cost, greater risk, and a lower reliability. To use smaller bricks to make greater buildings, there will be more joints needed, and all these joints will not directly provide service to the customer. However, every joint will increase the cost and the potential risk of failure for the building, which is not only increase the overall cost of the construction, which reduce the overall reliability of the whole building. The second is the excessive power capacity results in the unavoidable waste. 2-hour cell is more like an athlete for the sprint, which requires immediate explosive power and which requires the very strong heart and muscle. However, if we ask the sprint athlete to run a marathon, then all these enhanced design for the explosive power is useless, which has already become the unnecessary cost and the burden. So simply put, to have the 2-hour cell for the 8-hour energy duration is equal to use a small component to build a very complicated machine, or to use a sedan to equip it with the engine of a sports car to run a long distance is either reliable nor economical. And this is the same idea for the 4-hour cell to serve the 8-hour energy storage. So to realize we think that for the 8-hour energy storage scenario needs the 8-hour long duration energy storage dedicated system, and an 8-hour long duration storage system requires purpose-built 8-hour cell. So what makes developing a dedicated 8-hour cell challenging? The longer duration of the energy storage has a higher requirement for the economy. So the first challenge is, while we meet the scenario performance requirements, and how do we reduce costs on the basis of 2-hour and 4-hour cell?
In addition, in order to enhance the reliability and economy of the system, of course, we want a bigger capacity of the cell. However, the higher capacity would bring about bigger challenges for the cell and its security. So we need to ensure the whole life cycle security and reliability while raising the capacity of the cell. If we look at the history, we could see that HiTHIUM has taken very early action, committed to technology research into the long-term, long-duration energy storage of the lithium-ion batteries in 2025. We are already put into mass production of InfiCell 587 ampere-hour and InfiCell 1175 ampere-hour for 2-hour and 4-hour energy storage. And today, we are going to take one more action, and we believe the real breakthroughs will be based on the ultimate pursuit into the deeper understanding of the scenarios and also the technological innovation. And we've built the dedicated cell to the 8-hour energy storage, and this will be the InfiCell 1300 ampere-hour 8-hour long-duration energy storage cell, which is not only just a product, but also a champion cell to deal with the challenge and also to pursue the excellence. This is of 3 core values. First is the large capacity and ultra economy. Because of the 1,300 ampere-hour cell capacity, which is 4 times higher than the mainstream, so it has reduced 30% of the number of components of the system, effectively reducing the initial cost of investment for energy storage stations. That is higher economy, and at the same time, it enjoys higher security and higher reliability. We've built up a multi-layer security protection system so they could pass all the rigorous security tests without diffusion of the thermal runaway to guarantee whole life cycle security. And at the same time, the longer duration also delivers a stable return because the cell could support more than 25 years of service cycle, providing a solid guarantee. And this dedicated 1,300 ampere-hour cell, specialized for 6.9 megawatt-hour long-duration energy storage, provides a champion cell. But how was a champion cell built? Because when the system capacity increases from 6.25 to 6.9 megawatt hour. 1,300 ampere hour cell would become the optimal solution for a balanced economy, reliability, and thermal diffusion. Based on 4-hour cell, this has increased by more than 10% in capacity. It is not just a numerical change. It is also a profound revolution based on 8-hour energy storage. We can see this is a composition of the cost of 2-hour cell, and it includes the power components and capacity components. And when it is supporting 2-hour energy storage in order to support the high power output, the power components occupy more than 35% of the total cost. However, in the scenario of 8-hour energy storage, the power needed is only 1/4 of 2-hour cell scenario. It means that we have the space to customize a cell for the 8-hour energy storage scenario to reduce the power cost. And the key lies in the decoupled design of power and capacity. So the long duration energy storage cell will not pay the cost for the high power of a short duration. And we boast our in-house technology of battery. This significantly enhance the electrode thickness so that we could reduce the cost of the power components, including foil, for the 8-hour cell, more than 50% lower than the 2-hour. So it is not to use the race car for long-haul transport. It is to design a dedicated, durable vehicle for the long-haul travel, which will be of a better cost and economy. But of course, we can see the 3 key challenges of the electrode structure and also the low transmission speed, as well as the difficulties in electrolyte infiltration. And at the same time, we enabled collaborative innovation of the electrode design and the chemical system, breaking all the barriers in technology. In terms of safety, we also designed a guarantee system with a multi-layer protection system, which could effectively curb the propagation of thermal runaway. And secondly, we reduce the reaction activity of LFP service under high temperature and high voltage, so the cell would deliver more stable performance in such circumstances. And at the same time, in extreme environment, our design could guarantee the venting of the gas from within the cell, compared with a smaller capacity cell. We've created more space for venting, and these optimized multi-layer outlets, air outlets, would avoid fire and explosion of the cells. In terms of performance, to tackle the bottlenecks, we innovated the electrode structure, and also we customized the raw materials and the process. On the one hand, we adopted the differentiated electrolyte formulation, and with also the segmented electrolyte injection and membrane forming processes, we could ensure both thorough infiltration of the electrolyte into ultra-thick electrode and the construction of a highly stable electrode circle interface. And we've innovated the microstructure of graphite. So this forms a solid kernel of the champion cell. And in terms of our R&D deficiency, we face a common challenge of verification of the long-duration energy storage cell. And with AI empowerment, we shorten 50% of the material development cycle, and also the evaluation cycle of the service life of cells has been shortened by more than 70%, which ensures our fully proved reliable solution. Based on these breakthroughs, I have confidence to say that long duration energy storage would see HiTHIUM's solution as the optimal solution in the industry, and it represents the next generation. And we hope that we could work together with you to take all the opportunities of 8-hour energy storage market sector. Last but not least, I would like to use this one sentence to end my presentation. We may be born ordinary, but all greatness springs from a heart longing for championship. And this champion cell dedicated to long-duration energy storage will help us to win an endurable victory of the green future. Thank you all. And of course, this all starts with AIDC, and it will break through bottlenecks and empower infinite possibilities. Let's enter the AIDC chapter together.
The advancement of industry requires the firm practice. And now let's please welcome our next speaker. Let's welcome SC Solution Director, HiTHIUM Power Quality Shanghai Company Limited, Mr. Liu Zhihua, to share with us. Hello everyone, I'm Liu Zhihua from HiTHIUM. After listening to the HiTHIUM solution, I'm quite impressed, and I would like to share some of my insights because I've been working in this industry for over 20 years. So for the energy storage utilization in our data center, which be more dominated by the 340 ampere hour, and then for the 500 or the 600 ampere hour. But now we have seen the 8-hour 1,300 ampere hour cell is very impressive. And the theme for today is the long-duration energy storage. And in the industry, and HiTHIUM is combined with the backup supply or the energy storage in terms of the power supply to the data center. I would like to share some of our ideas. And let me give you some share. And this is when Elon Musk said during the interview, and we know that the Elon Musk wanted to develop the energy in the space, but now it says that the overall energy is actually more important. And it's like when the AI has taken over the labor, money is useless. The advancement of a civilization will depend on energy. So energy is very important. And this is Amazon. As we all know that the data center of OpenAI, and Amazon has another data center called AIDC, and we could see that you will build 1 million chips data center with the electricity consumption reached 2.2 gigawatt. However, there was one issue, that electricity in the US is not enough. The overall utility scale can only provide 50% of the energy, electricity consumption, and 47% needs to build in-house. And also, for the 47% are coming from the combustion, turbo combustion, the wind power, photovoltaic, and the energy storage. It also needs to build a small-scale nuclear power plant as well.
Moving on, this slide shows what was introduced in the white paper by NVIDIA. Within the system, which seems quite complex, but if we divide it into modules, this part highlighted in gray is called SST. Of 10 kilowatt or 35 kilowatt transformed to 800 volt. To solve what problem here? We could see this is a power supply router to support power load of one rack, which is around 1.1 megawatt. And here the SST in the center is of 3.5 megawatt. And it is equivalent to 4 racks together with one transformer, from which we could tell the importance of energy. So a 3.5 megawatt transformer could only support 4 racks, which is hard to imagine. Under such circumstances, we would believe how important energy transformation could be. And this is also our solution, MV Energy Router, which is 5.4 meter long, 1.6 meter deep, and 2.2 meter wide. And this kind of cabinet is replacing our transformer. In China, the standard would be 10 kilowatt, and maybe in overseas it would be higher, up to 35, which would convert the voltage into 800 volt for DC to use. And from here, we can see more clearly that the power is sourced from the grid. Through the system, it is converted to 800 volt electricity. And then it would be used for the wind PV and storage integration. And then it could help us address the expanded need of electricity. And in data centers in China, usually this would be up to 15 minutes. But in the overseas community, we know it could be shorter. And we are also aware of the insufficiency of energy in those overseas areas. So if we turn it into 800 volt, if it is with the 1,300 ampere hour solution, we can see what would happen. But of course, in terms of overseas supply of power, usually diesel engines would be used also for the power generation for the urban areas. So this solution would be quite economical, of a very good cost performance. And here, this is the MV Energy Router to replace the conventional solution. We have the MV transformer and also the power distribution cabinet to support the power load. And with this whole set of infrastructure, it's only several cabinets to support. And maybe to meet the power need of these several cabinets, we don't need that kind of complex system anymore. This can be simplified as a solution. And moving on to the current status of this energy router, since NVIDIA announced their solution for 800 volt DC power supply, this has been flourishing, and many companies have launched their solutions based on such concept. And of course, they're in different stages in terms of progress. Some are still just a concept, and some is already deployed with research and development efforts. And this is an example installed in China, in Sanhe, Hebei province, with input of 10 kilovolt and 800 volt DC as output. And the sources include the sodium-ion battery installed outdoors. And also this is a lead acid battery for storage. And as the DC AC devices installed here, it could support the IT load up to 1.2 megawatt, a dynamic load. And I think this has been the very first system to be installed industry-wide. It is not in large-scale mass production yet, but one very important application with the system is on energy storage. It is not only for data centers, but also for energy storage. By next year, a dozen systems of this technology will be installed to charge electric vehicles. Together with the energy storage system, it could be used for peak shifting, because during the daytime, the charging electricity price would be more than 1 RMB, nearly 2. But actually, if the energy could be stored and if it could be used during the valley period, it could be a very efficient solution. And then why do we call it an energy router? Because, you know, we have the term internet, and also we have the bit internet, and now this is what we call a watt internet. It used to be just a one-way flow from the grid to the load side, but now the electricity of this equipment, it could flow from the grid of 10 kilowatt to the load, to the load side, and it could be the other way around as well. And with this, we could construct an energy internet. It used to be one-way flow of energy within certain area. It could not be two-way or cross-industry park flow of energy, but now it is changed. With the energy internet, energy could be shared by more stakeholders then. One more innovative application with this technology is also about the internet. This is a typical UPS structure. On this, you could see this in the middle, the energy storage battery could supply power to the consumer side or the load side. Energy flows that direction, and usually it would be 15 minutes of backup power. But if we want to use it in the long duration power supply scenarios, this time period could be extended. But if it cannot be absorbed, we can use the number 4 technological approach. So it could be flowing back to the utility grid. And then those utility systems could consume the electricity. We talked about medium level voltage energy, and this is of a lower voltage level. And it is also two-way available. This is quite advanced solution as well. One more pinpoint to address. When we talk about long duration backup power, we may also face some request of non-intermittent storage and power supply. So with energy storage and also with the UPS feature, we can realize a power solution with energy storage plus UPS. And then the system could even be replaced, and the cost is reduced. And one more thing is about the extreme volatility of AI power loads, which would be influencing the power grid, causing the instability of grid. With this solution, empowered by energy storage, we could also ease the volatility of the grid. The volatility of the load could be eased so that it won't influence the grid performance. Some companies engaged in energy storage have been quite interested in this solution. I share this with you today very briefly. If you want more details, don't hesitate to talk to me. But of course, this system has been deployed as a pilot program in Inner Mongolia. So a number of functions of this system this is a waveform of the test so that the unremitting power supply could be realized. And this is a switching time no more than 2 milliseconds, and it is not influencing the power load. And also it could be compensating the waves so that the harmonic waves could be removed with this innovative approach. And the product looks like this. This system is of a very high power density, and the whole system could be up to 2.5 megawatt, so the power density is quite high. To wrap up, since we always say that the end of AI will lie in energy, and since we've got an energy storage system, we still have an intelligent power dispatch system for unremitting power supply. So with energy storage, with our solution, we can form a synergistic industry chain, jointly contributing to energy development in the era of AI in a more intelligent and future-oriented way. With the battery, with this system, we could enable more effective energy management and two-way flow of energy. One more thing to briefly introduce our company. HiTHIUM, a listed company with a history of 102 years. We are dedicated to power management and electric and electronic product development. Thank you all. This is all from me. Thank you, Mr. Liu, for the very informative sharing. Throughout AIDC's development, HiTHIUM has consistently pondered that facing the harsh energy challenges of the era of AI computing, how can we move beyond the traditional backup power thinking and reconstruct the energy supply and dispatch paradigm for AIDC? And now, with the warmest applause, let's welcome Dr. Naza Yi, board member and vice president of HiTHIUM, to reveal the answer for us. Hi everyone, I am Naza Yi from HiTHIUM. Nice to see you all again. So from Professor Tan and Mr. Liu's presentations, we've already seen the grand blueprint of the rise of computing power. But there's also a fundamental question for us to answer. So when computing power surges like tsunami, how can we make sure that our energy system could undertake that? And today I'm going to offer you the answers from HiTHIUM's perspective. And as we all know, we are greedy for computing power now with the comprehensive explosion of AI technology. From 2020 to 2030, the overall computing power need has exploded by more than 100 times. And also for the 100 megawatt level data centers, the number has increased more than 60 times of these kind of data centers. And behind every bit is a watt. So we can see that power as a driving force is a key. By 2030, if we see the global data centers, as a digital country, its power consumption will be more than 1,500 terawatts, and it would be the fourth biggest power consumer globally. And we could also see that we are faced with some challenges. First is about the imbalance between iteration of computing power and the infrastructure of power. And the former is moving forward by years or by months. And for the power infrastructure, it is also being very slowly constructed and planned. And just as the CEO of Microsoft said that we have a huge amount of GPU overstock in the warehouse, it's not because of a lack of need, but because of the shortage of power and space to deploy.
Second is the conflict between computing power expansion and the carbon neutral target. And for the 1,500 watt-hour future data center power consumption is still mainly from the fossil fuel. Then the overall the emission of carbon dioxide will be the 580 million tons, and this is the total annual emission of UK and France, and which is run in opposite direction for a future green future. And in order to make breakthroughs, and we are dedicated to build a new energy system featuring agile deployment and the green carbon, low carbon deployment, and to build the from source to load method. And from the source side, we wanted to build the accelerate for agile deployment. Our plan is to have the high efficient coupling and the smart management with the long duration energy storage of HiTHIUM with the solar power and wind power. And this combination will actually shorten the overall construction cycle of the energy infrastructure from 5 to 10 years to 1 to 2 years. And to reach where computing power is planned, green electricity will be guaranteed simultaneously. And when the computing center has the green electricity proportion requires over 80%, and for the 8-hour long duration energy storage solution value will be shown extremely. And so economically, it will significantly reduce the cost per kilowatt of the green energy. And in terms of the robustness, it can realize the frequency regulation to guarantee the power resilience, high quality supply. And in terms of the reliability, it can provide the standby power, the micro black start, and many other scenarios to provide the solid support. However, is solving the source alone enough? Of course not. We also need to focus on the load side. We found out AIDC is actually a new impacting load that has never been seen by the grid. You will have the frequent and intense power fluctuation in the over 10 milliseconds, and the range can reach 70%. And it is more like on the highway, we have a large amount of the supercars, which will have the emergency brake and accelerate at the same time. And this impact is catastrophic to the grid. And when it's become more severe, it will have the power grid blackout. And that is why we need to have the second protection on the load. And today, HiTHIUM has created the collaborative lithium-sodium energy storage solution. What we call is the directional stabilizer for both power and energy. For the high-power sodium-ion BESS, it's more like a precise sniper. It has the high-rate discharge and is responsible for the instant stabilization. And it will be like a precise sniper to actually eliminate the massive and rapid load fluctuation, and to build the first electromagnetic barriers for the grid. And our self-studied the sodium-ion cell does not only have the excellent performance, can also provide the ultra-long service life with over 25 years, and the overall system efficiency improved by 3%. And the HiTHIUM lithium-ion battery backup system is a reliable reserve team. It can partially or fully replace the diesel generator with loud noise, strong pollution, and a slow response. After calculation in some areas, by using the HiTHIUM lithium-ion battery backup system, and it can the overall backup cost in the 4-hour backup duration can reduce over 20% compared to the traditional diesel generator. This is not only a rational choice from the economic point of view, it is also the green responsibilities of a corporation. And we will turn the vision of zero carbon backup power and the silent backup power into reality. Let me give you an example. And the 100 megawatt AIDC with the 3 megawatt hour sodium-ion battery system and the 200 megawatt hour lithium-ion battery backup system can realize the two dual benefit. They are, on the one hand, the sodium-ion system can have the load fluctuation reduced by 70% with a response time over 5%. And then on the second hand, lithium-ion can reduce the backup power cost up to 40%. And also in terms of the implementation, our plan has compatibility and forward-looking, and it will come, and also to the current electric architecture, we can seamlessly connect. And also through the HVDC, next generation high efficient system, and our plan is the natural adapter. And through the replace AC with DC, and also our system efficiency is improved by 2% and response time further improves 2 times. Born for AI Plus, and a full duration energy storage solution for AIDC, and are flexibly equipped with the HiTHIUM energy storage Infi Power series product, and to construct the overall energy guarantee system from the energy source to the load, and also systematically respond to AIDC's core appeal in terms of the green, agile, stable, and economy. And also wanted to share our HiTHIUM's AI concept. We're not only an enabler of AI developer, we are also the practitioner of AI plus energy, and we have already embedded the AI technology into our R&D, manufacturing, and operation and maintenance, and making our own AI plus industry into the best practice. And today, on behalf of the HiTHIUM, I would like to initiate the Build the Energy Foundation for AIDC. And we also appeal and sincerely invite all the companions in the industry to work with us and to dedicate ourselves into this course, which is concerned for the future competitiveness and energy safety. And now I would like to close my speech with empower AI with sufficient electricity, empower the world with a green future, benefit a whole population with green energy. Thank you very much. If we want the industry to better and systematically understand the logic of such reconstruction, and we need authoritative research results that can represent both industry and practice and professional research perspective. And now we're going to witness the launch between the HiTHIUM and the Gaogong Industry Institute. And this report is based on detailed industry data, cutting-edge in-depth insights, and a systematic professional analysis, aiming to provide a solid foundation and a forward-looking compass for the development of the industry. And now let's please welcome Director of Research Institute, Gaogong Industry Institute, Gao Xiaobing, to share with us on the 2025 Global AIDC Energy Storage Industry Development Blue Paper. Good afternoon, everyone. I'm very honored that Gaogong Industry Institute can work together with the HiTHIUM to draft the 2025 in Global AIDC Energy Storage Industry Development Blue Paper. Let me share with you on the content. And we know that there are 2 major directions in the science, which is new energy and AI. New energy, including the generation, transformation, energy, and utilization. And we also involve the wind power, hydropower, photovoltaic, and many other renewable energy. And the innovation, the breakthrough of renewable energy will break the barriers based on the fossil fuels or unbalanced distribution of fossil fuels. New energy is mainly based on the continuous breakthrough of technology. And AI is the knowledge-intensive, talent-intensive, and the investment-intensive industry. It actually linking different industries, and which will also penetrate into every corner of our economy and society. We can feel that when the new energy plus or the AI plus, but I think what is very interesting is actually new energy plus AI, which is the synergy opportunity and also the mutual benefit and a mutual reliance. And what we are seeing right now is more about challenging and anxiety. And from the global technology leaders express of anxiety brought by the AI to the energy. And this is very evident. And based on the estimation by different institutions, we could see that the global computing power scale from the 2020 to 2030, we will see over 50 times increase. And also the energy consumption in data center will also see 4 to 5 times increase. And by 2030, China, Europe, data center electricity consumption will account for 4 to 5% of their total energy consumption. And the United States will also reach 10% of their total electricity consumption. So in terms of the AIDC chips, safety and architecture and energy efficiency, it has posed new requirements, for example, like the high power density, high energy efficiency, the gigawatt level, and a large power. And we could see for the single unit power can transfer from the 10 or 20 kilowatt to 100 or 500 kilowatt or even to the gigawatt, which will create exponential creep. And for the overall power utilization efficiency of the rack has already reduced from 1.6 to 1.1 or 0.5. So for the overall energy efficiency, we could see the overall efficiency has transferred from the to the 98 or 99%. And then we could see for the AIDC or the solid state technologies emerging. And for the application of such new technology has posed new ideas or requirements to the power supply amount and the quality in our data center. And in order to ensure the stability of AIDC and also to adapt to the fast power fluctuation and the long-term requirements, we have provided some solutions. For example, like the UPS can have the stabilization of voltage and which can provide a stable and pure power, and for BBU can respond in the milliseconds to meet the instant power requirement and also to provide instant electricity for the core component in our data center, and then to guarantee the large economic loss caused by the data loss due to the power outage. And we know that the AI has a huge change in terms of the power, and for the power consumption can instantly improve from 30% to 100%. So if we introduce this large energy storage systematic solution, which can actually smooth the voltage fluctuation and also to solve such pressure, when under the extreme conditions, the large storage can provide many hours or even days backup solution, and in some cases can directly replace the traditional generation system and to serve as the long-term backup plan. And in the area with abundant new energy resources, then the large energy storage can integrate with their new energy resources and to provide a more autonomous and a stable power supply to AIDC. And in overseas, with the photovoltaic energy storage, cost is approach to the fossil fuel, and also the global technical leaders has already made commitment to realize 30% of data center electricity coming from the green electricity in the United States, Middle East, Malaysia or the German are actually deploying the large AIDC. We think that overseas, the PV and wind power energy storage can provide a more flexible, economical, and the high efficient electricity. And in China, we have deployed the top 8, the algorithm hub, and the top 10 computing power cluster, and also which has provided the way for us to solve the deployment issues and also to solve the coupling of electricity and computing power. With the high power, low electricity consumption, and a high energy efficiency requirement, we think that AI energy storage is a very important support for the development of AIDC. And we also think that AIDC energy storage will receive an explosive growth. We think that by 2030, the AIDC energy storage shipment will reach 300 gigawatt hour, and many will come in from the China, Europe, North America, and many other regions. And from the product structure, the out of cabinet large storage will take the largest proportion. And with the large demand, a lot of companies are joining in, and globally there are over 50 companies are developing products with surrounded on AIDC energy storage. And whether it's the regulating on the peak or the frequency or the emergency response or the backup, we think the creation or capability of a cell is the most important, to have a long duration, high security and high frequency and high response manufacturing company go into the AIDC energy storage will have a good advantage. And the HiTHIUM is meeting the industry demand, and with using AI are providing us with a solution which will tackle the pain points and the difficult points of the industry, and also to bring the innovative and a long duration solution for our industry.
This is also how China's power is contributing to the global challenges. Due to time limit, I will just stop here. Thank you for listening. Thank you, Mr. Gao, for your excellent interpretation of the blue paper. Please stay here, and next we will witness the moment symbolizing industry convergence into jointly complete the blue paper release. We will sincerely and warmly welcome Mr. Jeff Wu Zuyu, founder and chairman of HiTHIUM, and Mr. Jason Wang Pengcheng, co-founder and CEO of HiTHIUM, and Secretary of Party Leadership Group and Vice Chair of Xiamen Association for Science and Technology, Ms. Ouyang Lijuan, and Executive Deputy Secretary General of Energy Storage Branch of China Battery Industry Association, Mr. Zhang Jian. Let's together gather industry strength and embark on a new journey of AIDC. And let's witness the 2025 China AIDC Energy Storage Industry Development Blue Paper. And please, thumbs up for our common future. And dear photographer, please capture this memorable moment for us. Thank you all very much for lighting up this key moment. And please return to your seats kindly. And next, we will move to the final segment of today's event. We are honored to invite Mr. Jeff Wu, founder and chairman of HiTHIUM, to deliver a closing address. Please. Distinguished guests, good afternoon. I am Jeff Wu from HiTHIUM. After listening to wonderful presentations delivered by our dear experts and my dear colleagues, and also I would like to, based on their conclusions, share with you more about my own personal perspectives and also HiTHIUM's practices. And as introduced by my colleague as well, in July and August, China's monthly power consumption exceeded 1 trillion kilowatt hour. And for the whole year, it would be more than 10 trillion. And globally, it will be more than 30 trillion in terms of the newly added electricity consumption. And by 2050, the world's total power consumption will be more than 60 trillion kilowatt hour. So in the next 25 years, the additional power demands of the whole world may be 3 times China's current total power consumption. And the drivers behind include electrification and also the rise of AI, as well as industrial decarbonization. Let's look at electrification of vehicles, first of all. Penetration of EV in China is expected to be more than 60% even. And it's estimated that by 2050, with the brand new experience delivered by autonomous driving, by that year, full electrification will be realized globally. Because EV alone will occupy more than 10% of the total electricity consumption. And we also estimate this to be the biggest power consumer among all other scenarios. As we discussed AI a lot, and I also checked the latest data, the daily token usage globally is more than 100 trillion. Combined with AI surge and higher efficiency, we believe that by 2050, AIDC power demand will account for 8% of the global power consumption. These two combined is equivalent to 18%. Approximately China's total power consumption now. So the huge additional power consumption is a great challenge to the traditional energy structure because it is not only more power consumed, it also represents our pursuit of the green future, which is also a wonderful opportunity for new energy and for new electricity and power system. As HiTHIUM, a market player in new energy sector, I would like to answer this question together with you. Can renewable energy replace conventional energy sources and support the future power demand? Well, we all know that this is the future. But as I've listened to our experts' presentations and discussions, the most frequently mentioned pinpoint would be the cost. And HiTHIUM has also proposed quite bold ideas to discuss with you together. In order to address this challenge, or in order to make this formula happen, wind and solar green power generation cost plus power transmission cost plus energy storage cost, the combination of these 3 costs, let's analyze them one by one. Power generation and power transmission are not that expensive. But for energy storage, it would be much more expensive. It is even more expensive than the traditional or the conventional power cost. And in order to make this combined cost lower than the traditional energy cost, in order to make this happen, what will happen then? It will then bring about 150 terawatt hour of new demand. If we just talk about 1 terawatt hour, it is nothing compared with 150. And it must be of a very high economical performance. So this kind of installed capacity, which is huge, including LFP batteries and sodium-ion batteries, as well as other types of long-duration energy storage technologies, this will create tremendous opportunities, and it will be a mega industry exceeding 100 trillion skill. So, facing the super track, we also propose a key concept here. Economic viability of energy storage will drive full marketization of energy storage technologies. We talk about its economical viability. It is not to compete with low price. It is to create a bigger market space. And with this huge market space, this industry will then witness explosive growth to be successful. So as HiTHIUM, we offer our solution. We target that in the next 5 years, with technological innovation and optimize the cost, LCOS for energy storage will enter the era of 0.1 RMB. So we need to downsize the combined cost by 3 times in the next 5 years. And what should we do more specifically? First of all, energy storage should match the lifespan of wind and solar, but also to match the cost of wind and solar. So this is what we're thinking about first, to deploy ultra-large cells featuring high safety, long lifespan, and high energy efficiency. We can't stop mentioning ultra-large cells because in 2022, HiTHIUM, together with other companies, launched the cell product with 200 ampere-hour. We, at that time, made our commitment to raise the efficiency, to also prolong the lifespan, and also to enhance safety. And now we are at 1,300 ampere-hour after 1,175 ampere-hour. We are aiming at the next breakthrough so that we could consolidate the energy storage foundation to offer the optimal solution with both safety and a lower cost. And secondly, we're dedicated to developing energy storage system with superior safety, integration, and efficiency. Dr. Guan mentioned 4-hour and 8-hour energy storage, and you also noticed an increase from 6.25 to 6.9 megawatt-hour. It seems not a big improvement, but actually it integrates energy storage technologies combined with AI algorithms to optimize the auxiliary power consumption to be reduced and to save the cost as well. And we, of course, hope this could help lower the price and cost of the energy storage system. And thirdly, we advance extreme intelligent manufacturing with our new Shandong base as an example. Its single-line production capacity increased to 15 gigawatt-hour, and also the manufacturing cost per unit decreases by 45% already. This is just the beginning. We aim at more advanced capacity, like the other bases in Chongqing and in Xiamen, to enhance it up to more than 97.6%. And we will manufacture the PBB level energy storage base. So this is a third aspect that we aim at. And fourthly, we would implement integrated solutions. From energy storage battery components to integrated solutions, we provide full-stack solution, and we are dedicated to building a more resilient global supply chain network. And hopefully, this kind of integrated solution and services would be more competitive to satisfy our clients. And some people may be very pessimistic. They believe that LFP battery is already at the end. But actually, based on our experience, we believe LFP batteries enjoys still great potential. According to Alex, not sure about how much time of energy storage could be provided by lithium-ion batteries, but I think in the track of 12-hour energy storage, LFP battery has no rival. So we believe that more innovative technology will be the sharp weapon to reduce the cost and also to popularize the green technologies. So we are empowering more AIDC scenarios with our innovative energy storage technologies, and we'll continue to empower zero-carbon parks, smart cities, and intelligent microgrids. So green electricity can be beneficial for all industrial sectors. So dear guests and experts, we never compete against our counterparts in new energy. We are competing against the conventional energy, facing the new business formats of AI with electric vehicles and also electrification of basically all industrial sectors. HiTHIUM is willing to work together with all partners to promote technological innovation and widespread adoption of green electricity so that we can let green energy benefit all. This is a very brief presentation from me. Thank you.
请佩戴同声传译设备的各位来宾。
Guests using simultaneous interpretation headsets, please return earphones to the dedicated collection boxes at the venue. Exits before leaving. Thank you for your cooperation. We've also prepared a splendid dinner for you. Guests heading to the buffet, please present your wristband or meal ticket for orderly entry. Thank you for your cooperation.
Headset should be returned to the designated collection box at the exit when leaving the venue. Thank you for your cooperation. We have also